Assalamualaikum. We are going to present our project titled Student Grade Prediction. The team members are Nurul Nadia binti Muhammad Farul, Putri Nokamarina binti Ahmad Fazil, Azra Fadila binti Mazlan, Muhammad Harith Hamzi bin Abdul Latif, and Muhammad Fuad bin Hamzah. In this video, we are going to explain about our project's problem statements, objectives, methodology, data collection, data preprocessing, results, discussion, and conclusion and recommendation. This is the problem statements. First, students are worried with how well they do in online class. Some students have trouble connecting with their lecturers and interacting with their classmates, many of which have a negative impact on their studies. Second, students are worried if learning would give impact to their academic performance. The objectives of this project are to design a prediction model that predicts the student grade performance, to develop the design model, and to test the accuracy of the model.
Okay, now we go to the methodology. For this section, we will explain into 4 categories, which is the first one is data collection, the second one is algorithm, the third one is data split, and the last one is cross-validation. For data collection, we already collect 525 data obtained from 16 attributes from a survey. For algorithm, we already choose k nearest neighbor. And for this data split, we decide to use 80% of the data for training and 20% of the data for the testing. While the cross-validation, we choose the K-fold with value of 5 because we already have 5 team members. Data collection, we will use a data that we get from survey to create our prediction model. We have used a Google Form platform to collect all the data. About 525 data were collected and 16 attributes included inside the question, which are gender, age, student status, internet coverage, health condition, absence class, revision time, level understanding, level interest in theory, calculating, language, GPA for semester 1, GPA for semester 2, GPA for semester 3 and CGPA.
After data collection, we proceed with data pre-processing, which consists of data selection, data cleaning, and data transformation. Data selection. A total of 525 data has been obtained from the survey that has been conducted titled Student Grade Prediction. The data will be split into 80-20 ratio, which 80% is used for training data and 20% is used for the testing data in this model. Amount of 80% training is 420 data, while 20% testing is 105 data. The training data was divided into 5 parts, where each member has assigned in each scaffold listed in order to find the best setting with high accuracy result. Data cleaning. When there are some missing values in the dataset and the dataset will have incomplete data, hence data cleaning is required to be performed. Since there are no missing values in the dataset obtained from the survey, as demonstrated in the figure, the null value removal didn't require. Data transformation. KNN employs numerical data, so the categorical and nominal data must be converted. These are the figures before and after data transformation. These figures display a list of attributes that have been converted to numerical form.
Then, as for result, KNN classifier was conducted with different sets of parameters. The experiment we only changed the enablers values such as 2, 4, 8, 12 and 16. But for other parameters, we just use the default value. Then, second experiment, we changed the value of leaf size from 30 to 45. And using the same enablers value as first experiment, and the other parameters still use default value. Lastly, we change the value for algorithm equal to Booth, leaf size equal to 45, metric equal to Hamming, enables equal to 2, 4, 8, 12 or 16, P equal to 1, weights equal to distance. By using this parameter, we finally found the best accuracy for our model. Table below is a hyperparameter cleaning for each scaffold, and the highlighted column is the best accuracy among other parameters. All testing accuracy for scaffold get above 80% and the average is 82%. The difference between highlighted parameter and other parameter is it
and neighbors, which is 12. Then, pictures below show the final model accuracy score for training and testing by using the chosen parameter, which is the highest from the hyperparameter tuning. For training, we get 100%, and for testing, we get 86%.
As you can see at the right side, this is the 16 attribute that we input in our prediction model, and the result is showing that student will get 3.5 and above. Okay, this is the second example of our prediction. We insert the 16 data like I show in the right side, and the prediction result is showing that student will get range CGPA about 3.0 until 3.49, which is good. Okay, this is the last example of our prediction. We try to insert the data like I show in the right side, and then the prediction result show that student will get the CGPA range between 2.9 and below.
Next, I will explain about discussion. We split the data into 80-20 ratio for train and test. Then split it again into 5k-fold into 80-20 ratio too. The highest accuracy we got for a cross validation is 83%, and the highest accuracy for final model we got 86%. From that, we know that the accuracy of the data can be determined dependent on how the data is split.
As a conclusion, k-nearest neighbor is a simple machine learning algorithm that can be used to solve classification. And by doing this project, we can conclude that accuracy of both training and testing increased significantly after we tune the parameter. And by building this model, we can help students predict the CGPA, and the result can help them appraise them to make changes in their style of study due to the limitation of internet connectivity, preferred time of study, or study interest. As for recommendation, we might increase the data, as the accuracy of the testing for this model can be increased if the amount of data in the data set is larger. Another alternative that can we do to improve the model is by using other algorithm that can be used for classification, such as decision trees, random forest, and naive Bayes. That's all from us. Thank you.